I'm not sure, Tommy, I'm not sure if what we're going to do today is going to be new to some of you guys or if this is going to be kind of some review. I'm thinking it's going to be a little bit of both. I'm thinking the first part of this is going to be review and you're going to think this is pretty easy. The second part might be new to you. I'm not sure if you guys have done this in the past or not. So Friday we did adding, subtracting polynomials. What do you think we're doing today? Multiplying polynomials. Now, if you're doing a monomial times a monomial, that's pretty easy. We've done those. Like if you say 4x squared y to the third, that's a monomial, times 5x to the third y to the fourth, what's the only thing you got to do? So what do you do with the 4 and the 5? Times them, what do you get? 20. And what do we do with the exponents? We add them. So how many x's am I going to have? 5. And how many y's am I going to have? 7. And you are done. So multiplying a monomial by a monomial is a fairly easy thing to do. You just basically multiply the coefficients together, add your exponents. Simple? Now, what do we do, though, if we have a monomial times a binomial? Like 2x squared times x to the third minus 7. What do we have to do when we have a monomial here times a binomial? Distribute. So you have to take the 2x and multiply it by each part. So what is 2x squared times x to the third? Well, the coefficients we would multiply. 2 times 1 is just 2. And what are we going to do with the exponents? We add them together and we get 5. But then you also have to take the 2x squared and times it by the negative 7, which would give us 2 times 7 is negative 14, and I have 2 x's. Okay, so a monomial times a binomial like this, we're always going to distribute. So let's try another one. Let's say I gave you 8x squared y to the third times 3x to the fourth y plus 5x to the third y to the fifth. Let's say we want to do that. Well, distribute. What is the 8x squared y to the third times 24x squared y going to be? 8 times 3 is 24. 24. How many x's would I have? 6 of them. How many y's would I have? 4. So far, so good? But now I also have to take the 8x squared y to the third and times it by the second part. So the 8 times the 5 would be 40. How many x's would I have? 5 of them, because we're adding the exponents. Y to the third, y to the fifth would be y to the eighth. That part's pretty easy. We've done this before, right? We've done distributing before. Yes? Monomial times a monomial, pretty easy. Monomial times a binomial, all we do is distribute. What if it's a monomial times a trinomial? Like 2x to the third, we'll do y to the fourth, times 5x to the fourth y minus 3x squared y to the third plus 4x. Let's just do that. What do I do here? distribute it all the way through. Now you got to multiply by each part. So I'm going to have 10. How many x's? 7. How many y's? 5. 2 times the negative 3 would be negative 6. I'd have 5 x's and 7 y's. And I'm not done because now I got to do this again and times it by the last term. 2 times 4 would be 8. I would have 4 x's now and still 4 y's. So a monomial times any amount of terms. Hey, how we doing?
Good. Can you raise your hand if you're dressed in the senior citizen today?
I don't think anybody did. Slacking freshman.
Tomorrow's easy. Wear your cowboy boots or a polo.
Cowboy boots or polo? Yeah, half of them wear cowboy boots on a regular basis anyway, so there you go. Yep. Congrats, by the way, kiddo. Congrats, by the way. We're at the end.
What did I do?
You're graduating.
Oh, thanks.
That's nothing. That's no big deal. Okay, so a monomial times any amount of terms. If you have 8x squared times 2x to the 5th minus 3x to the 4th plus 8x third minus 7x squared plus 9x minus 11. A monomial times as many terms as you want. Just distribute. Take the monomial and multiply by each part. 16, x to the 7th. And we just multiply the coefficients, add the exponents. 8x times the 3x to the 4th would be 24x to the 6th. That times the next one would be 64x to the 5th. And then to the next term, and it would be, testing your multiplication skills now, negative 56 x to the 4th. And then to the next term of the 9x would be 72x to the 3rd. And then the last one would be 88x squared. That is something we have done before. Yes? A monomial times any amount of polynomial, you're just going to distribute fairly easy. I think we've got that stuff. But what about a binomial times a binomial? This I'm not sure we've done before. Have you guys done a binomial times a binomial before? All right, so here's the thing when you multiply anything other than a binomial or a monomial by any term. What you have to do, every term over here has to get multiplied by every term over here. So what we have to do is we have to take the 7 or the x, just the x, and distribute that through the next term. So if you take the x and multiply it by the 2x, you would get 2x squared. Everybody see where I got that from? Now you got to take the x and multiply it by the 1, which gives me the 1. So far, so good? Now you got to take the 7. We haven't done anything with the 7 yet. The 7 has to do the same thing. It also has to get distributed through there. So the 7 times the 2x would be 14x. And the 7 times the 1 would be 7. Okay? Now you just combine like terms. There's nothing with the 2x squared to combine with. But we do have 2 single x's that we can combine, which gives us 15 of those x's. And then we've got the 7. So that is what your answer would be. Now, how did we get the 2x squared? What did we multiply together to get the 2x squared? The x and the 2x. So what we did was we multiplied the x times the 2x. In other words, we multiplied the first numbers together, right? The first number here, the first number there. How did we get the single x? Where did that come from? That came from the x times the 1. In other words, we can call it the outside numbers, right? We multiply the outside numbers together. Where did the 14x come from? That came from the 7 times the 2x, right? Well, we can call that the inside numbers together. And then, where did the 7 come from? That was the 1 times the 7, or the 7 times the 1, right? We can call that the last numbers together. We do this so often where we multiply a binomial times a binomial, we come up with a little saying that we can use all the time. We multiply the first numbers together, the outside numbers together, the inside, and then the last. In other words, we FOIL. Okay? Whenever we multiply a binomial times a binomial, we have to do what's known as FOILing. We're going to multiply the first numbers together, the x and the 2x, those are the first numbers. We multiply the outside numbers together, the x and the 1, those would be the outside numbers. Then the inside numbers, so the two numbers that close together on the inside, the 7 and the 2x. And then the last two numbers together, so the 1 and the 7. And we call that FOILing. So let's try one. Let's FOIL. 3x plus 2, 4x minus 5. FOIL. What does FOILing mean again? First, outside, inside, last. Where are the first numbers? 3x and the 4x. What's 3x and 4x make? 12x what? Squared. Because that would give me 2x's, right? And then the outside numbers, so the 3x and the negative 5. What's 3x and negative 5 make? Negative 15x. And you got to be careful with your signs here. That's a negative 5. All the other three numbers are positive, right? So now the inside numbers, the 2 and the 4x would make positive 8x. And then the last. So the 2 and the 5 would make negative 10. You're typically never going to be done at this point, because you're typically going to be able to combine your middle terms. From the first and the last terms, those are generally going to be not going to have something to combine, but generally speaking, your middle two terms will be able to combine. So what's negative 15x plus 8x going to combine to make? Negative 7x. And that would be your answer. Okay? Now, a binomial times a binomial, you will FOIL all the time. But basically speaking, what you're doing, each term in the first binomial has to get multiplied by each term of the second part. It gets a little bit uglier when you do something like a binomial times a trinomial. What do you think we have to do here? Each term over here has to get multiplied by each term in here. How many terms am I going to end up with here? every term over here has to get multiplied by every term over here. How long is this next level going to be? How many individual terms am I going to have before I combine like terms again? Think of it this way. I had 2 terms here. They had to get multiplied by 2 terms here. I ended up with 4 terms, didn't I? So when I do a binomial times a trinomial, 2 and 3, how many terms am I going to have before I combine like terms? I'm going to have 6 of them. Because I have to do the 2x times, or just this 2x times each individual part. What is 2x times 2x squared? 4x to the third. Then I got to take the 2x and times it by the negative 4x, which would be negative 8x squared, right? Then I got to take the 2x and multiply it by the 7 again, which would give me 14x. I'm only halfway done because I've only taken the 2 all the way through. Now I have to take the 1 and distribute that all the way through. So the 1 times the 2x squared is going to be just 2x squared. The 1 times the negative 4x would be negative 4x. And the 1 times the 7 is a 7. So yeah, 1, 2, 3, 4, 5, 6 terms. Now, I'm not going to end with 6 terms because are there some like terms here that I can combine? Yeah. Where are the like terms? Well, there's nothing with the 4x to the third combined, but I have multiple x squareds. What's negative 8x squared and a positive 2? Negative 6x squareds. Okay. And then I got a 14x and a negative 4x can combine to make positive 10x's and just the plus 7. So I don't end up with the 6 terms, but as soon as you multiply, you will end up with 6 terms there. How many terms would you have if you did a trinomial times a trinomial? You'd have 9 terms. A trinomial times a trinomial. Now, you're not going to end up with 9 terms. But as soon as you multiply, you should have 9 terms. Because every term over here has to get sent through the second term. So 2x squared times x squared would be 2x to the fourth, right? Then the 2x squared times the 5x would be 10x to the third. 2x times the 3 would be 6x squared. So we've got the 2x squared taken care of, right? Now we got to do the same thing with the negative 3x. Negative 3 times the negative 3x times the x squared would be negative 3x to the third. Now you got to do negative 3x times the 5x would be negative 15x squared. Now the negative 3x times the 3 would be negative 9x. And I'm still not done. Because now I have to send the 4 all the way through. The 4 times the x squared would be 4x squared. The 4 times the 5x would be 20x. And the 4 times the 3 would be 12. So yeah, these can get really, really long. If you had a polynomial with 4 terms, and you multiply by another 4 terms, how long is that next level going to be? 16 terms long. Then you'd be able to combine like terms. So some of these can be very, very long horizontally. Now, we would be able to combine some like terms. We have an x third there, and we have another x to the third there, which makes 7x to the thirds. We've got 6x squared, we've got negative 15x squared, and a 4x squared. Let's see, those make 10. 10 minus 15 would be negative 5x squareds. And then we've got a negative 9 and a positive 20, makes 11 x's, and then just the plus 12. So that's what your final answer would be. But you can see where some of these can get really, really long. So far. And how many of you guys have done foiling before? Just basic foiling like these. Has anybody done these before? I'm curious. I don't know if you guys have done these before or not. Is this all brand new to you? No? Some of you? Okay. Number 12 from the homework. I haven't even told you what the homework is yet. I was actually just about to do one. Oh, not that one, but I'll do that one too. There's one more I want to do first. What would you do? What does this mean? If I put parentheses like that and put a squared on the outside, what does that mean? If I ignore what's inside there, what does something squared mean? It means you're multiplying it by whatever's inside by itself, right? So this is the same thing as this. Guys, I want you guys to see this, and I want you guys to fully understand this. This is one of the most common mathematical mistakes people make. When you see quantity squared like this, parentheses and squared, you absolutely have to write it out twice, and you have to FOIL. You got to do x times x, which would be x squared, x times the negative 3, which is negative 3x, negative 3 times the x, which would be another negative 3x, and then negative 3 times negative 3 would be positive 9. This is the answer. Okay? The reason I really, really, really want you to see this, I can't tell you how many times as a math teacher I have seen people take a problem like this and they tell me, oh, 4x squared would be 4x squared plus 3, or 3 squared is 9. And they would just square the inside. And that is absolutely wrong. You can't do it that way. When there's a plus or a minus in here. Now this is different than if it's times or divide. If that was a times or divide, you absolutely could do that. But because that's a plus there, there's no other way to do this other than you have to write it out twice and you have to FOIL. Now, there's still going to be 4x times 4x would be 16x squared. So if you squared that correctly, you would be correct on that part. There's still going to be a 3 times 3 is a 9. That part is still correct. But you'd be missing the middle part. You'd have 4x times 3 would be 12x. There'd be another 12x. The answer to this is this. What part do you think is most commonly forgotten? That 24x. I see people all the time take this and go, oh, 4x squared, that's 16x squared. 3, that's 9. And they just write 16x squared plus 9. but you're missing that middle part. This is such a common mistake. I've actually seen a meme made about this where the meme basically said, if you take this and you think the answer is this, okay? You know how like every time you step on a crack, you break your mother's back, or a bell rings, fairy gets its wings, or something like that, right? There's little sayings like that. I seen a meme that every time a student does this, somewhere in the world a puppy dies. Don't kill puppies. It's not nice. No, we want puppies to live. So don't kill puppies. Okay? What's missing out of this? How is this wrong? The middle term is missing. Okay? So what you really have to remember to do is 2x plus 3 times 2x plus 3, which, yes, there is going to be a 4x squared. And there is going to be a 9, but you're missing the 6x and the 6x, which the correct answer would be 4x squared plus 12x plus 9. Please don't kill puppies. Are we good? I wish I still had that meme. I can't find it. I've been looking for it, but I can't find it because it's really kind of funny. Yeah. Okay. Now, with that said, what do you think this means then? What do you think you have to do if I give you 2x, we'll do plus 1, to the third power? What does that mean? You have to write it 3 times. Now, whenever you have something like this, here's what I recommend you do. Ignore 1. Just multiply these 2 together, which means you're going to FOIL just 2 of them together. 2x times 2x is 4x squared. You'd have a 2x. You'd have another 2x. Did you?
Yeah.
Let me see it. Exactly. Yeah, see? That's the meme right there. Okay? That's the meme right there. I don't know if you can see the middle part there. Yeah. Good job. Send that to me. Email it to me because I always forget. Okay. Now, so we FOIL just these together, right? We sent the 2x through. We sent the 1 through. We get to here. 4x squared plus we'd have 4x plus 1. The problem is we're not done. Because what have we still not done yet? We haven't done that times the 2x plus 1 again. So now we have to do that one, which means, and you can do it either way. You can send the 2x through each way here and then the 1, or you can send the 4x squared through, the 4x, and the 1 through. It doesn't matter if you're going left or right here. You're going to end up doing the same amount of work. So you'd have, what, 8x to the third when you take the 4x squared through, 4x squared times 1, 4x squared. Now you send the 4x through, and you'd have 8x squared. 4x times 1 is 4x. 1 times 2x is 2x. 1 times 1 is 1. Does everybody see how I got that? And then, yeah, you'd combine like terms. So your final answer would be 8x to the third. What do we have? 12x squareds, 6x, and a 1. So you don't end up with as many terms as you think, but that's because we can combine. I'm never going to make you do this, but what would you have to do if you wrote it 7 times? What would you, what's the only way to do this? You'd have to write it out 7 times. You'd have to go 3x minus 1 times 3x minus 1. Foil those two together, right? Get that answer. Now, the nice part about this is you could foil those two together. And what's true about this answer and that answer? Should be the same answer, right? But that's only 4 of them. So then you got to do it again. 3x minus 1, 3x minus 1. Those two can be put together, and all 3 of those answers should be the same answer, right? But then you still got another 3x minus 1. And then you can foil these two together, get an answer. You can foil those two together, get an answer. And then you got to put those two. Yeah, it's a process. It's really long and it's really ugly. And there's really no better way to do that. So, am I ever going to make you do a 7th power? No. But if you look, everybody take a look at page 497. Look at number 61. What do you have to do for a problem like that? You got to write it 3 times. And then I would foil these two together, get that answer. And then multiply that answer by 1 minus x again, and then you can combine that term. Does that make sense? All right, Abby, you had asked a question. What number was that? 12? All right, 12 says 5m squared n to the 3rd times mn squared times 4m minus n. Well, ignore the 4m, ignore this part. Just multiply a monomial by a monomial. What's the only thing you got to do to multiply these 2 monomials together? What's that? That's a 1 there, right? Multiply the coefficients. 5 times 1 is 5. How many m's do I have? 3 of them, right? How many n's do I have? 5. Now, you got a monomial times a binomial. So you have to distribute. What's 5 times 4? 20. How many m's would you have? 4. How many n's would you have? Just 5 of them. Because there's no n's in this part, right? Now you got to take this and times it by the n. 5 times 1 is minus 5. How many m's would you have? Just the 3 of them. And how many n's would you have? 6. That is your answer. That is number 12. Does everybody see how I did this one? Multiply just these 2 together first, then distribute that through. Now, officially speaking, does it matter if I multiply these 2 first or these 2 first? Could I have distributed that through and then distributed that through? Yeah, I mean, we have that associative property where, does it matter if I go 2 times 3 is 6 and then times it by 4 to 24, or could I do 3 times 4 first and then times it by 2? It doesn't matter what order you multiply things when it's all multiplication. But are we good with these? Anything on here look insanely hard? All right.